Hi everyone, welcome to this video where I'll be discussing k-means clustering. So in this lecture, I'll be discussing what is k-means clustering, how does it work, when it is best applied, and what are its advantages and disadvantages. Okay, so what is k-means clustering? So it is a clustering method used to group data objects within the dataset to create non-overlapping subgroups. So you have this big chunk of data where there's a need for you to segment it to different groups to identify common behaviors of each data. So this is an unsupervised machine learning technique, and K refers to the number of clusters that you want to group your data into. Okay, so how does k-means clustering work? So as mentioned, k-means clustering aims to partition the dataset into several clusters that you have identified, depending on how many data clusters you want to partition it into. So you can calculate for the means resulting to a Voronoi set for groupings. So it follows an algorithm repeatedly until it reaches the optimal cluster where there is no longer repetition. So how does it work in actual? So for example, I have here a series of data in a line. So there is no immediate distinction or label about these data. So you just know it's there, but there's not really much for you to identify it into. You will need to, from the set of data points where there's no immediate distinctions or label, you have to select the number of a number of distinct points based on your number of k. So these data points will be initially assigned as the centroid. Then all you need to do is assign the remaining data to the nearest centroid. For this case, I have identified four data points as my distinct data points identified immediately to be the centroid. I have here K1, K2, and that's an amber. K3 is the green, and K4 for the blue. As mentioned, that after that, I'll have to assign the nearest data point to that centroid or significant the distinct data into it, so I can immediately cluster it based on this number of distinct data points. So in this case, I have here K1, so there's 2 points for K1. K2 I have 4, so from the center point of K2 there's 3 data points that is nearest to it, and then K3 there's 2 data points in that, and K4 there are 4 additionally from that, so that makes it 5. So that's the initial cluster of all my data points based on the distinct centroid that I identified. Okay, so after we manage to assign all the data points into their respective clusters, their initial clusters, I would say, next is what we will do is, after we assign them, the distance of each point to the centroid is calculated for us in order to measure the variance. So the distance from the first point, so you'll see here, the first point, the distance of it to the K1, it's being measured. The K1 is also being measured to the next points, and so on, and it follows. All of the data points will be measured to one another, so for you to identify what is the variance and how far each point is from one another. So after that, once you identify the variance, all you need to do is you will have to reassign it. So reassign it to minimize that variance. The centroids are being reassigned to the best possible point that there is to it, and that basically how the cycle should go from moving forward. You'll measure it and see the variance. As long as the variance is being reduced, there's no stopping for you to you have to continue doing this process. The machine will do it in actual until it reaches the optimal clustering where there are no more changes to the centroid. Okay, as mentioned from the previous slide, next is you have to repeat that process until there are no more changes upon recalculation of the means to the distance of the other points, and your clustering is already in its optimal setup. So in this example, so you'll notice this is just an example that there are several changes in the centroids upon iteration, after a series of iterations, performing the process over and over again. So that's there is no stopping for you on doing it, or the machine has to continue doing it until it identifies its optimal setup. Actually that's the primary gist of k-means clustering. It's the last step. All you need to do is you have to repeat it. Okay, so when do we apply k-means clustering? So as mentioned, the aim of k-means clustering is really for you to segment your data into such significant clusters that behaves the same way as they one another. So it aims to reach that optimal setup. So it is best applied in several fields of business, engineering, research. It's really a diverse technique that is being used today, especially in machine learning. And for example, you can use k-means clustering for marketing. So if you want to identify your customer demographics, what are their common interests, what are their preference for your targeted marketing campaigns. Also for production optimizations, in the shop floor, for example, you can use k-means clustering for you to put manpower on an optimal number of zone assignments. You can use k-means clustering on that and identify the optimal count of service points. So as mentioned, so you have your entire shop floor and you know your process. You can use k-means clustering to know how do you zone it out and with equal level of work. Also for logistics and supply chain, k-means clustering can also be used to achieve the optimal trucking assignment based on customer geographic locations. So you can assign routes that will be equal to another route that is your process is taking. Okay, of course, just like any other method, k-means clustering also has its advantage and disadvantages over the others. And one of its advantages is very simple and straightforward. As I mentioned, all you have to do is you have your data set, identify points, calculate distance, or repeat the process over and over again until you minimize your variance and achieve that optimal setup. So it's very simple and straightforward. It can cater to large data sets and it can easily adapt to data set changes. So whenever you insert another volume of data, it will, especially in machine learning, it will automatically calculate. It will learn. It will adjust to the data that you inputted, and it's really very adaptive to that change in data. It can also generalize clusters on various shapes. However, of course, as I mentioned, there's always a disadvantage to any method, regardless of what technique it is. So k-means clustering is dependent on the initial k value. So actually there is a scientific way to calculate k value, but this one really works more on a rule of thumb that and it's pretty manual to begin with. For your initial, you have to handpick your centroids. It works that way, but there's also a scientific way for you to calculate your k. And it's another disadvantage for this is it's clustering the outliers. So regardless if your data set has some abnormal data or outliers, once it detects this data, it will automatically capture that outlier and include it in the calculation of the clusters. Okay, and another is it scales the data set. It's a very sensitive model in terms of data set count. Actually, this can be an advantage and a disadvantage as well. So it's very data set sensitive. Once you insert something, the results will change. So it can also have that disadvantage to it. So either way, it's very dynamic in such a way that the data is really moving towards whatever you input it will adjust itself automatically. Okay. And as I mentioned, once it captures the outliers, another disadvantage is it has a uniformity effect. So regardless what is the abnormality within a data, or if there's anything that is not normal on one data point or two or so, regardless, it treats that data as uniform with the others, regardless of there's a certain variable to it. So, but it has this uniform effect. Okay, before I close it, as I mentioned, before we end this video, I just like to highlight the summary of what k-means clustering is. It's really a very simple and straightforward. I couldn't emphasize it enough that it's really one of the most simple and efficient machine learning methods out there with very diverse applications. Regardless of what kind of business or industry you are in, it's really an effective way to cluster your data based on their commonality and based on their behaviors. So part of this advantage of being simple and straightforward is it's really easy to apply once you have that knowledge and once you have the infrastructure to it. So yeah, I think that would be it for this video. Thank you very much for listening, and I'll see you again soon. Thank you very much.